Hey guys, welcome to Fix Make Learn. Today we have a induction oven to fix. Now this induction oven over here is dead. The owner told me that plugging it in trips the MCB. Let's see what is wrong with this one. And I'm not going to plug it in because it maybe trip our MCB or blow the fuse also. So let's open it up and take a look inside if we have any short in the input circuit or not. I removed all the 6 screws. Now let's see. We don't need the top cover now. Now this is the inside. Now to get to the SMPS, we need to remove the coil. Let's start to open the coil. Now we can remove the coil. We have a multimeter in diode mode. Now first, let's check the continuity. We have continuity. Now first thing we're gonna check if we have short on the power cord. It's not short. We can remove the power cord from the board and check for connections. We don't have short in here. Let's check the other one. We don't have short in here, so the power cord is okay. Now let's check the fuse. The fuse is good. Let's check the bridge rectifier now. These two are AC cord. AC cord don't have any short, and the diode is showing short in here. The we have short on bridge rectifier, but that doesn't mean that the bridge rectifier is gone. Let's check another thing. And it's also showing short on the IGBT. So if the IGBT is shorted, maybe we have short also on the bridge rectifier. So first thing we are gonna do is remove this PCB. This is the fan and this is the input output connector. We have another screw in here. Let's remove it. Now the PCB is out. Now as we have short on both of these components, we need to remove them one by one and let's check for short. So let's remove the IGBT first. I have my solder sucker in here. The solder is removed. Now let's try to remove the IGBT. The IGBT is removed. Let's check if the IGBT is shorted or not. And as you can see, the IGBT is shorted. It's completely dead short. Now let's check the bridge rectifier again. And we don't have short anymore. So the IGBT was causing short in the board. Now we will replace the IGBT, but before that we must check some things. As you can see, we have some resistance, a resistance over here, and I can't see any driver transistor. And I would like to check this section carefully, because if anything else is bad in here, it will short the IGBT again. So let me take a look and then we'll replace the IGBT. Okay, I have tested some components on the board and did not found anything wrong in here. So what I'm going to do now, I'm going to clean up the board a little bit and then we will replace the IGBT and hopefully we will get this thing fixed. I'll do the cleaning things later. For now I'm just cleaning this area because after installing the IGBT we won't be able to clean this one. I removed these two resistances to check them. There are mentioned value in here 820k 1 watt. I have tested each of them and both looks good. So let's just solder them back. Now let's solder these resistances. I have applied some flux. The finish of the solder will be better. Looks good. Another thing I wanna check is this diode. The diode is good. So everything literally looks good to me. This capacitor looks like it's shorted. I'm not sure. Oh no, the capacitor is not shorted. Actually, the coil is connected in parallel with this capacitor. Now we have the same number of IGBT. It's 25N120 and like this. This one was from Fairchild and this one is from KGF. Both of them are of same specification. Now to install it in here, we need to bend the pins. I bent the pin little bit, and I also have some heatsink compound gum. I'd like to apply them before installing the IGBT. Yeah, looks good. The IGBT is in its place. Now let me clean these extra heatsink gums. Let's solder the IGBT. I'd like to apply some flux again. This way the soldering will be smooth. Let me push these pins little bit so that we don't need to cut down the pins. Let's solder the pins. Okay, we have soldered the IGBT. Now let's clean up the area and then we will check. Let's check for short again. We don't have short. Don't have short in here, so looks good. Now before we plug it in, I would like to replace this fuse, one side of the fuse, and I'll attach an electric bulb in here, so that if we have short anymore in the input side, nothing will get destroyed. Now this is the electric bulb we are gonna use, but before that, let's remove the fuse. If anything goes wrong, the bulb will take the load in place of fuse. Okay, so let's put everything back. It was like this. Let's put back the fan. Let's put back the IO panel. Yeah, we also have to install the sensor. Okay, the sensor is in place. We have line. We have neutral. And now we are ready to check. Okay, so everything looks good. Now let's power it on and see if it's blowing my fuse or not. I don't have proper arrangement in here. I don't have a 16 ampere fuse, 16 ampere MCB in here, but as we have the bulb, we can check if it's turning on or not. Okay, so moment of the truth. And as you can see, it's turned on. Let me turn off the light so you can see the lights in here. The fan is on. We need to put something on it before it functions. Let me get a bowl or something so that we can turn it on. Okay, so we are ready. I put some water in the bowl, and now let's turn it on. And as you can see, it's trying to, let me lower the power. It's trying to drive the IGBT, but as the bulb is in here, the bulb is taking all the load. So we have to test it by removing the bulb. So let me remove the bulb, and we can test in here because this is my computer setup and we can't use high ampere appliances in here. So let's move to the dining table. There we have the high ampere MCB connected in there, so it will be safer to test this in real time. So after give it a nice and neat clean, it's look like this. The fan is clean, everything is looks good. Now I was not able to clean this one, so I just left as it is, but I've cleaned the whole thing. Let's turn it on, and if I turn it on, now it's waiting for any container, steel container or something. Let's put this one on this. It's working on 1300. It's not. Let's reduce it to 800. Let's turn it off. Now after using induction cooker, you should keep it on until the fan goes off, because the internals need to be cooled down, and that's the only cooling is done by the fan. So the fan will sense itself when everything is cool, it will goes off. So you should wait till that time until the fan goes off.